My name is Konrad and I'm a staff software engineer at Ocado. I'm here today with Mariusz.
Hey, I'm Mariusz, product manager at Ocado.
And first of all, you might be wondering why there's two of us. We won't be talking at the same time. Unfortunately, we only got one mic, although that would be funny. Yeah, so the topic here is going from a cool hackathon idea to an actual product. So to cover such a topic, we thought it would be best to cover it from two perspectives. One is the engineering part, so how we came up with the idea, how we implemented it, and another is how we actually turned it into a product, how we measured its value, and so on and so forth. That's why there's two of us, and we'll take you through the journey of developing our product from those two perspectives. What we will be talking about is our product called the OTP Assistant. OTP Assistant is a chatbot that answers questions about our internal platform called Ocado Technology Platform. Ocado Technology Platform, abbreviated as OTP, hence the name OTP Assistant. This is just like a short mention of the name so that you know what we are talking about. More details about how it became a product, what is the product definition, and so on, later on. So, how did it all start? It started with a technology. As all of you are aware, large language models are something that is hugely popular right now. It's a technology that a lot of people see a lot of potential in. And to be completely honest with you, we thought it was kind of cool and we wanted to play with it. So just to be on the same page, what such a model is, it's as the name suggests, a model that models language and is able to understand and generate text. In principle, it is very simple. It takes some text as an input and generates the next part of that text, the next word or the next piece of a word or something like that. So in principle, it's something very simple. Those models are special because they are trained on a ton of data. And this was surprising to many people because there is no technological advancement throughout the last couple of years when it comes to large language models, when it comes to their architecture or how they are done. But most of the advancements come from the fact they are trained on more and more data. And in the past, models developed by OpenAI, models like GPT-1, GPT-2, were more of a curiosity. You could use them to generate something that looked like code, looked like stuff written by Shakespeare, but you couldn't actually use them for anything. But then around GPT-3, 3.5, and then 4, something cool started to emerge. So those texts generated by those models actually started to make sense, actually started to reflect reality. So what we thought, yeah, it looks cool. It would be great to be able to use it at our work, because that would make us probably more productive. It would be just fun. Who ever thought something like that about a technology? Yeah. And who has actually taken this technology and created a product around it and introduced it in your company so that it's allowed for everyone? Yeah, so hopefully with this talk, we can show you, not to you because you already did that, but to everyone else, how something like this can be done. So where do we even begin? It's a huge topic and it does seem kind of difficult. First advice is don't try to convince people after watching a couple of videos and playing around with the technology for a day or two. You don't have enough convincing power to convince your product manager or your leadership to actually build a product. You need more time. How do you get more time? Fortunately, at Ocado Technology, we have a concept called Slack days. So if you have an idea you think is cool, you can take those Slack days and try something new. Try something that maybe is not related directly to the main stuff you are working on. That's what we decided to do. We agreed with our leadership to have a hackathon, and we would spend 2 days of the entire team on playing around with large language models. But just playing around with them wouldn't yield anything actually useful. So we decided to focus on a single and concrete use case. Without that, we would have some research, maybe some cool demo that doesn't work when we actually want to demo it. And by focusing our efforts, we decided maybe we will be able to actually create something working and useful. We thought to ourselves, ChatGPT is cool. Everybody has used that. But the questions that are actually most difficult to figure out are questions about our internal tooling, our internal infrastructure. To get answers to those questions, I'd either have to, ask a teammate, ask for support, search from some kind of documentation. It's much more difficult. So if ChatGPT knew our internal context, it would be 10 times more useful. That was an idea we had, and then we thought to ourselves, we need data. And our advice here is, don't use confidential data. So if you want to use confidential data, you will need to be fully compliant with probably some kind of list of technologies that are approved at your company. If you want to do that, it's very likely the new technology will not get approved because you don't have a concrete business use case for that. Or it will take a lot of time and you will not proceed with the idea. What we recommend is trying first with something that is already publicly available. We are very lucky to have something called Ocado Technology Handbook, which is already publicly available. You can type it in Google and take a look at it. And it's a list of practices and development standards that we use at Ocado Technology to deliver our software with great quality. So we thought it was great because it was company specific and it was already publicly available. So we could use it with an unapproved technology without having to ask for permission. Last but not least, definitely not least, we recommend aiming to have something working and lovable. So let me paraphrase. A POC is worth 1,000 words. If you come to your product manager and try to explain that this new technology is going to change the way we work and is going to improve our productivity 10 times, I guarantee that your product manager has heard that speech 100 times and probably will not listen to you. But if you show them something that is actually working and actually delivering value, then it's a different conversation. So what we wanted to have is an assistant that would know the handbook and could help developers write software that is aligned with the Ocado Technology Handbook. So how do we go about it? Our first idea, it's a machine learning model, so it would be good to train it. So actually embed the information into the model itself. As it turns out, it's not how it works. With large language models, you don't extend their knowledge usually by training. Training a large language model, as the name suggests, requires huge amounts of compute, huge amounts of data, and it's simply not feasible to do it especially for a POC like this, to actually extend the model's knowledge this way. So, what is this model training? What can it be useful for? It can be useful for guiding the model towards a specific behavior. So if you want to, for example, have a model that responds in a formal tone, you can use fine-tuning to do that, but you cannot use the fine-tuning to add more knowledge. So another idea was the input to those models can be quite long. What if we put the information needed to answer the question within the question itself? It was working relatively well when we provided simple examples with a piece of the handbook and a question about that piece of the handbook. But we ran into another problem. The length of the model's input is limited. For the model that we've been using, GPT 3.5, it was 4,000 tokens, which equals about 6 pages of text. The Ocado Technology Handbook is much longer than that. So once again, we had a solution that doesn't work. We had to pivot. We wanted to have something working at the end of the day, We didn't want to say that, yeah, that something cool is possible, but we didn't do it. So we decided to focus on a piece of the handbook that is relatively small, but would show our concept at least. So we decided to focus on the hallmarks. The hallmarks are a specific part of the handbook that are concrete development rules that have to be followed for application in Ocado. And with that, we were able to fit into the model's context length, and we had something working. And now hooray. And now we had to ask ourselves, is it good enough? Is it good enough to turn it into a product? First of all, it was not useful on its own. The hallmarks document was fairly small, and it was most of the time quicker to just search through it than to ask the bot. Second of all, we didn't see a clear path of extending the model's knowledge to everything in the company. So without those two, we didn't think we had a product. But we had something cool enough to convince our leadership for another hackathon. And we set the goal for the second hackathon to address those two problems. First of all, have a larger knowledge base, have something maybe more useful, and second of all, have something scalable. So what did we use? A lot of you might already know this abbreviation and this architecture, but there is like a popular architecture in the large language models world is the RAG architecture, or the Retrieval Augmented Generation. Sounds complicated. In practice, it's quite simple. So let's start with what we have. We have the Ocado Technology handbook, and we know it doesn't fit into the model's context as a one big block. So we have to obviously split it into chunks. That was fairly easy. But now what? How do we know which chunks to put into the question, which chunks are relevant for which user's question? Luckily, there is another type of model that is also becoming more and more popular nowadays, and those models are called embeddings. Embeddings are models that take stuff, for example text, and convert it into vectors in a very nice way. So the vectors that the text is converted to actually represent the meaning of the text. What does that mean? We take text, we convert it into a vector space, and within that vector space, the vector that represents the word cat is close to the vector that represents the word kitten. What does it mean once again? It means that if we search through that space, we can search by the meaning of the words and not by keywords. So if a user asks a question, we are able to retrieve information based on what they meant and not what words they used, which is hugely useful and allows for much more accuracy. So we do have that. And with that, we had to also handle the user's interactions somehow. So we take the user's question, we transform it to the same transformation, we transform the chunks of text. We search within the vector space for chunks of text that are similar when it comes to the meaning to the user's question. This process is called semantic search. And with that, we take a couple of results, let's say 10, 15, 20, and we embed those into the LLM's prompt. So we have something that works once again. Is it good enough? First of all, we figured out it was useful for ourselves. At the time, we've been developing a library that had to follow the handbook, had to follow the guidance outlined in the handbook. So instead of trying to search through the handbook by head, we asked the bot. And what we figured out is there is a lot of stuff in the handbook that we were not aware of that is regulated, or there are some recommendations about that we wouldn't have found or wouldn't even have thought to search if we didn't use the bot. So instead of searching through the documentation on our own and missing stuff, we had something that was more accurate than ourselves. it was also scalable, so we had a clear path of the development forward. Yeah, we have something working, and probably as engineers, when you have something working, your first instinct is to make it better, iterate on it, maybe break it. So we recommend you not to do this. Why do we do that? At this point, we invested, let's say, 4 days into this project. If we come to the product manager and the product manager tells us we completely don't have time for this idea now, we would not be sad. We spent 4 cool days working on a cool project. We can live with that. But if we implement 10 more features and get emotionally invested, it would be much more difficult to let go, and it would be like a very sad experience instead of a happy one. So with that, we had a working prototype, and we thought to ourselves, it's time to talk to the product manager. With that, I'm handing over to Mariusz.
Yes, hello everybody. Does it work? Yes. Okay, so I'm Mariusz, I'm product manager at Ocado. So we are talking here about guiding AI innovation. So I have good news for you. You're not alone in this journey, and product manager can help you. So today I want to tell you basically what we did with this particular product and how, what kind of work I did, and I think it will be kind of inspiration for you moving forward. So this situation was new to us in many dimensions. First of all, there was a new technology used, which was not kind of officially yet kind of approved to use in our company. We are a team that we also have our product portfolio. Our roadmap was fully packed with already planned activities. So we have to justify what we are working on. It increases productivity of our software engine. So there is a certain value in that. Like I said, it's a new technology. So first thing I had to understand is that what is this technology about? So first term was Gen AI. So fair enough, it generates, it's basically Gen AI, it can generate something. But what was more important, the second term, that was what is the foundational models. Coming from the world when models has to be trained, tested, and actually you need for some portion of time data scientists in the team in AI project. Here the model is delivered by third party, so you can, with software engineering skills in your team, you are able to build AI system. That was a good information because our team is fully staffed with software engineers, but we don't have data scientists in our team. So why I had to understand that? Because I had to understand this technology to understand all the limitations, but also possibilities, right? And LLMs is part of the text. It's basically large language models. So in Gen AI can then generate text. So the next steps, what I did is trying to understand how LLMs are being used worldwide. So basically, what are the practical implementations of LLMs in business? So we found those 4. We noticed that the team was kind of exploring self-service question answering and a kind of augmented bots. And we decided to park code generation and translation because this requires a bit of, represents next level of complexity. So the next thing what I needed to understand was basically so how it all fits into our business, so what we are doing here. So we are using all cloud providers in Ocado, and we with Konrad work in the team that provides Ocado Technology platform. This is basically a layer on top of cloud, all the cloud providers where our software engineers are building their software. So Amadeus, who is a platform user, but also software engineer, when joining Ocado, you have to learn this platform. This is a proprietary tool. You're not able to learn it in the city. So what kind of option you have? You can either browse documentation, which is complete but heavy at the same time, or you can raise a ticket to the platform team to ask something very specific. Yes, so that's our business scenario. So our product hypothesis was that we would like to try either this or that. So we want to improve one of this process, either searching documentation or helping in support. So we started with the research. trying to figure out basically what's going on in this space. So first, I analyzed support, and we ended up that 10 of our teams received over 6,000 tickets a year, which we found significant. And since we are in the large language model space, the second research was how many of those tickets, the answer to those tickets can be found in the documentation. So that 7 out of 10 teams confirmed that the significant number of the amount of questions, so number of the questions are described in the documentation. So we say, okay, good enough. So there is a potential in it, right? So we have data. Basically, this is what it means. Second analysis was related to the user. So in such a situation, we can have typically 2 approaches. One is we have typically tangible and intangible benefits. So we started with tangible, something that we can calculate in man days or dollars ultimately. So we said that let's assume a certain minutes per day that software engineer is spending on searching documentation. So if we multiply this by number of software engineers, we should end up in the tangible benefit. Yeah? So let's see how much it could be in our scenario. We assumed rather low number of 10 minutes for software engineer, and because the scale we are running here at Ocado is massive, we are having 1,300 software engineers, we ended up with 27 man days. So basically, with the assumption of 10 minutes spent on searching documentation, it means that 27 engineers are being paid just for search information in our documentation. To better visualize it, it means that if we can save those 10 minutes, we can deliver every day a double-decker full of software engineers that can do something else. Yeah, basically can do more productive work. So that was tangible benefits evaluation, but I was also continuing more external research, trying to understand what is the overall impact, because we had a feeling that this exact calculation might be not enough on the user end. And we have found this GitHub survey, which was run on even more number of engineers, when they were confirming that easy to source documentation improves engineering productivity by 50%. And since our department is responsible for software engineers' productivity, that was enough for us to justify this work. So, but also we had to define what our product will be doing. And we decided to attack these 2 business problems. So we said that OTP Assistant will answer all platform-related questions in close to 0 time to address 2 problems, to increase engineering productivity and reduce the support burden of our support team. So we basically want to build a product for both group of users. What was also important, we are talking about the time like mid-23, something like that, so it was quite some time ago. So what I'm trying to say is that the ChatGPT was popular, but not as popular as today. So people are starting asking questions. So why build? Why we cannot use ChatGPT? Why there is no? Why we have to build something on our own? So this differentiation factor was built around our proprietary tooling, right? Because basically our assistant will be able to know our own platform. No one else can fit any AI model with this information because we are the owners of the platform. We are if there is someone who has to build such a solution, it's us. We cannot. This documentation will never be public. So that was good differentiation factor to basically justify. So we have business value and product and differentiation factor. So with this, we decided to continue.
Yeah, thanks. So, yeah, that's something
easy to say.
Yeah, we convinced the product manager to go with the product. Now we have a product defined. We kind of asked for it, yeah? So now we have to actually build it, and there are some challenges. First of all, more data. So initially we built it on a small subset of data that was publicly available. So that's something we have to address. And we address it in, let's say, two ways. First of all, we had to start using proprietary data that is not available on the market. So how to do this? We, fortunately at Ocado, have a process for making decisions with some degree of risk. We don't have to avoid all risk, we can take some risks. And feeding internal documentation, proprietary documentation, into a tool that is not yet approved for use was such a risk. So we asked our head of engineering to accept such a risk, and thanks to the fact that we already had a product definition, we knew there is value. We had a working prototype, we had a chance to be listened to. If we didn't have that, we wouldn't be listened to, because who accepts a risk if they don't see a value? Another thing that we had to do is actually formally request the technology to be added to the tech stack of the company. And once again, it was only possible because we had a concrete business value. Somebody has to evaluate this technology, somebody has to add it, somebody has to make sure it's safe. So to justify this effort, we had to have this business case. So what kind of data do we want to use? We wanted to use good quality data, and preferably data that we already know something about. So when it comes to good quality data, we obviously chose our own documentation, because our documentation must be good because we wrote it. On a more serious note, we picked also a team that is known for the quality of their documentation, and we collaborated with them to add their documentation. This process was, let's say, lengthy and took a lot of steps, because we are taking somebody's documentation, feeding it into some kind of a solution, and giving it to their users. So it's not obvious that the team will be happy about it. It's not obvious that the solution is going to work. But it's a complex product-related topic. To do that, we actually had to run a series of experiments. We are happy to talk about it a little bit later on, but we weren't able to cover it within this presentation. Another thing that we had to do is build trust with the users and with the teams that give us data. As already mentioned, there was a series of experiments, but to give you a hint of what we had to go through is initially we didn't show the answers to the users at all. We only showed them to the business experts who could use them in their support requests. Second step was to actually allow users to ask questions directly, but only in a public environment where those answers could be audited. And the last step was users being able to ask questions privately without nobody reading them and checking their bot's answers. Last, but definitely not least, we had to figure out how to test such a solution. And it's a very interesting challenge on those two topics, building trust and testing. I invite you to the follow-up talk that will be done by Adam. He will cover hallucinations and testing, and more in depth when it comes to technical terms. One thing I wanted to note is testing should be explained and done on the very beginning. So we've run into lots of problems because we didn't have a concrete definition of what the bot's answer should look like. We had some intuition. Everybody had a different intuition of how such an answer should look like. And for large language model project, a definition of a test set of questions with golden answers that are approved by stakeholders is basically what requirements are for any other software project. So I wouldn't start any other large language models project without first defining a good benchmark data set that I can use to measure it. The architecture we ended up is quite similar to the RAG architecture I've showed you before. We've extended it with support for multiple documentation sources because teams across Ocado use different documentation formats. If you are of a keen eye, on the previous slide you might have noticed that we used a YAML file as a database. In the final architecture we've solved that problem and we used something called a vector database. with semantic search, it's very, very popular to use a vector database. Vector database allows you to use a query, something like an SQL query, but when it comes to vectors and their distance. So normally you would query by a value of a column, but in a vector database you can query stuff that are closed in a vector space. So those are specifically designed for that. The answering engine also didn't change much, but I wanted to use this opportunity to show you how the query to the LLM is built. First, we have some kind of an answering guideline. So explanation of how the answer should be formed. In our case, we, for example, don't allow the model to generate code, or we don't allow it to use its external generic knowledge. We ask it to strictly follow what is written in the documentation and only base its answers on that. Then we follow it up with the chunks of the documentation. We add the previous conversation history. So those models, large language models, are stateless. They only generate the next word. So if you want to actually make the model aware of the previous conversation, you have to embed the conversation history into the prompt itself. And last but not least, we add the user's question. We needed some kind of user interface. And we had no front-end developers. So we decided to have something quick, have something we could set up easily without front-end experience, and we used Slack. So the bot is available as a Slack bot, so you can tag it in a channel and it will answer your question. You can send a direct message to it and it will answer you there as well. What have we learned throughout all of this process? First of all, we recommend trying to provide value as soon as possible. What does it mean? It means having happy users as soon as possible. You don't have to build a fully complete, elaborate solution. You have to have something that delivers value that you can build on top of, and you should validate it quickly. And there is nothing more beautiful in the world than a smile of a product manager, and there's nothing that brings a smile of a product manager more than a happy user. So how do you do this? You have a limited amount of time. How do you do this? First of all, you cannot focus on front-end if you don't know front-end. You have to focus on stuff that gives you the competitive advantage. Instead of building front-end, we use Slack to save time and focus on making the solution actually work on what it's designed to do. Secondly, instead of focusing on translation, code generation, and so on and so forth, we focused on one thing and we decided to do it in a world-class way, or at least try to do it as well as we can. Another thing is those kind of innovative products and creating new products in general, it's difficult. There's going to be pushback, there's going to be skepticism, and this is warranted. It's not that every idea is great. There's something to every idea probably, but not every idea can be turned into an actual product. But what we recommend is not getting discouraged by that, but actually trying to learn from that. What we have learned from initial pushback that we've got is that we needed to have more concrete expressions of business value. And this is when we decided with Mariusz to actually, instead of talking about bringing more productivity, to calculate it in a tangible way, to convert it into Mondays and then dollars. And along the way, there were things that we didn't like, but we had to compromise on. So initially, we were kind of disappointed when we had to hide the bot and only provide the answer to the business users. But we had to build trust. We had to go step by step. Nobody would give us their documentation and access to their users if we didn't show them what this solution is capable of first. So we had to be okay with compromises early that we could challenge later, but without going for those compromises, we would not have a product today. In such a short amount of time that you will have for that project, we recommend giving yourself and the idea the best chance possible. To do that, use the biggest model you have access to, use the largest context size you can get. Focus on optimization and speed later on. If you don't do that, you will end up thinking, is my solution not working, or is it a problem because of the model is too small? So instead of that, give yourself every chance you can, and the same applies to the quality of the data. We chose an exceptionally good documentation to start, which we knew it was great. And if the bot worked on this documentation, it had a chance to become a product. If it didn't work on this documentation, we would know it's not a good idea, because the documentation quality was exceptional, it wasn't a variable we had to control anymore. AI projects are data projects, so to hammer down on that point once again, we couldn't have done it without people giving us their data. What does it mean? It means that the data quality mattered. So we started with an exceptionally good documentation, but what we saw emerge was actually people taking our bot, looking at its answers, and improving their documentation based on stuff the bot got wrong. So we came to the conclusion that if the bot is getting something wrong, it's quite likely that the user would also not understand it, because it's probably not written in an intuitive way. So we created a feedback loop where people are actually making their documentation better based on the bot's answer, and thus making the data quality better. We also, once again, to hammer down, need business experts. So when we added our documentation, we knew what to expect, what the bot should say. But we are Python developers. And when we added a Java library, it was like some kind of Elvish to us. So we needed to have good collaboration with our friendly teams that helped us understand and judge the quality of the answers. Last, but definitely not least, be responsible, especially when it comes to AI. It's going to be a hot topic more and more. And how did we actually do it in the assistant? First of all, we are transparent about what is happening with your data. So you are informed that your questions are going to be, for example, gathered and analyzed for let's say, accuracy analysis purposes, but it won't be like shared with everyone in the company. So we are transparent about this. And even more importantly, we try to not mislead. Maybe not as strictly as doctors, so first do not harm, but we try to make sure that the bot's answers, that one wrong bot's answers doesn't ruin the savings generated by 9 good answers. So we actually optimize the bot for less good answers, but also less bad answers. We would rather miss an opportunity to have one good answer than to have one wrong answer instead. And with that, I would like to thank you. I would like to close the presentation.
Follow up.